Hi and Assalamualaikum everyone. We are from Group 6. We will present our experiment 6, which is Bourdon tube laser gauge. Our group members are Nurul Syahira binti Ibrahim, me, Siti Nurul Abidi Ali, Sumaiwin and Wan Muhammad Syafiq bin Syawaludin. Abstract. The objective of this experiment is to perform pressure calibration on a Bourdon tube laser gauge using a deep weight tester. This experiment is carried out by placing piston into the cylinder and air bubbles inside is removed by rotating or push the piston. The pressure gauge deflects as the piston is put into the cylinder for the initial reading. And one by one, load weights are added till the total mass reach 5.5 kg and the procedures are repeated for increasing and decreasing weight load. This experiment is conducted successfully as true pressure is almost the same as the pressure recorded. The input reading is the weight on the piston produce a known pressure in the vessels equal to the weight divided by the piston area, while for the output reading, we can get it from the pressure gauge. Next is introduction. One of the most important steps for maintaining instrument accuracy is instrument calibration. It is the process of setting up an instrument to get findings that are within a reasonable range. A deep weight calibrator has been used to apply known weights to a plate in order to determine the accuracy of pressure gauge readings. Many types of pressure measuring instrument has been used to measure the pressure intensity at any location in a static or flowing fluid. The Bourdon tube pressure gauge is one of the devices that has been used because of their dependability, compactness, low cost, and also ease of use, and it is made out of a curved tube with an oval cross-section bend into a circular arc. For example, it's like the figure 1 that I have put at this slide, where it have the weight, quick support, and Bourdon tube pressure gauge. The objective of this experiment is to calibrate a Bourdon tube pressure gauge using deep weights and also to compare the experimental results with the theoretical values. Theory. The Bourdon gauge is the most popular pressure measuring device for both liquids and gases. It can be connected to any source of pressure, such as a pipe or vessel that containing a pressurized fluid. The first one is Bourdon gauge. The Bourdon gauge is fitted with a transparent dial, which lets us to see the internal workings of the gauge. The gauge consists of a thin wall closed-end tube, which is oval in cross-section. This tube is bent through an angle about 270 degrees along its long axis, and the open end of the tube is welded to a hollow mounting block which allows the pressurized fluid to reach the tube. This causes the pressure from the source to be transmitted directly to the inside of the Bourdon tube. The applied pressure causes the oval tube to become rounder because since a round cross-section has the maximum area for the given circumference. As it becomes rounder, the Bourdon tube tends to uncurl, which causes its free end to move. A system of linkage and levers transmits this motion to the gauge needle which moves over the scale. As you can see at figure 2, where the Bourdon gauge have a dial, pointer, Bourdon tube, and piece, link, quadrant, move point, and also stamp with pressure connector. Second is deep weight calibrator. It is important to recalibrate the gauge on a regular basis in order to acquire extremely precise pressure readings. This is due to the tube's tendency that degrade with time, and the standard procedure is to use the device that called a deep weight calibrator to deliver a known pressure to the gauge. And the standard calibration procedure is to use a deep weight calibrator with a non-specific gravity liquid to load the gauge at known pressure such as water. And then third is equations. The theoretical pressure equations if P equals to F over A, where F is equals to mg, which is we get P equals to mg over A times with 10 power of negative 3 kilopascal. where F is the force that applied to the liquid in the calibrated cylinder, which is in Newton. M is the total mass, that including the mass of the piston in kilogram, while A is the cross-sectional area of the piston in the square meter, and lastly is G is the acceleration due to the gravity in meter per square second. The applications that related to Bourdon tube pressure gauge are used to measure medium to very high pressures, and then they are also used in measuring high pressures, for example in steam boilers or in compressors, and then lastly they are used in measuring our vehicle's tube tire pressures. That's all from me. I will pass to the next presenter.
So I will explain the methodology part in this experiment. For the first step is the cross-sectional area of the piston and the mass of the piston and dead weight was not down. And for the second step is the piston from the cylinder was removed and the oil was poured into cylinder up to its overflow level. And for the next step is we need to test the gauge reading was ensure zero before inserting the piston. And for the fourth step is the piston was placed into the cylinder carefully to reduce friction effects. The transparent tube was tightened and gently tapping or rotating the piston softly to remove the air bubbles trapped in the cylinder and tube. And the fifth step is the pressure gauge was measured when there is no weight on the piston and the reading was recorded as the first pressure gauge reading after the system is stabilized. And for the sixth step is a single dead weight, which is 0.5 kg, was added on the piston and the reading of pressure gauge was recorded after the system is stabilized. And for the step 7 is the step 6 was repeat until the total mass reached 6 kg. And after that, a single dead weight was removed and the reading of pressure gauge was recorded for under after the system is stabilized. And the step 9, the step 8 was repeated until all dead weight are removed. And for the step 10 is the step 3 to step 9 was repeated for 2 times to get the average pressure gauge reading. And for the last step is the apparatus was cleaned and dry off the piston plugger with a least free cloth. Now I will pass the presentation to my beloved member. Thank you.
My name is Sumevan. I will explain on the data and result for experiment 6. As you can see from the table below, the table is the data from our calculation. The cross-sectional area of the piston is 3.1731 times 10 to the power of negative 4 meters squared, and the weight of plunger and platform is equal to 1 kg. When zero mass added is equal to the weight of the plunger and the platform. So first, you have to calculate the actual pressure exerted by the piston, which is mass of the piston equals to 1 kg times 9.81 times 10 to the power of negative 3 over cross-sectional area of the piston. Then you have to calculate the actual pressure exerted by total mass, which is equal to total mass. Total mass is weight plus the piston, and you times 9.81 times 10 to the power of negative 3 over cross-sectional area of the pistons. Then for the calibrated pressure, which is taken from the Bourdon gauge reading, for increasing order of weight, you have to take 3 readings and you find the mean. Same to the decreasing order of weight, you also have to take 3 reading and then you calculate their mean. Mean is equal to reading number 1 plus reading of number 2 plus reading of number 3 over 3. Then you have to find the percentage error for increasing order of weight and the decreasing order of weight. For percentage of error for increasing order of weight, you have to use the formula mean of increasing order of weight minus pressure exerted by total mass over pressure exerted by total mass times 100. Same goes to for the decreasing order of weight is mean of decreasing order of weight minus pressure exerted by total mass over pressure exerted by total mass times 100%. This is the graph for calibrated pressure versus theoretical pressure for increasing order of weight and decreasing order of weight. For y-axis is the calibrated pressure, which is Bourdon gauge reading, And for the x-axis is the theoretical pressure. The blue line is for increasing order of weight and the orange one is for decreasing order of weight. That's all from me and I'll pass to my next teammate. Thank you.
Hi, Assalamualaikum. My name is Nur binti Ibrahim. I will present about discussion and conclusion. So let's see the discussion. First, percentage of relative error for the theoretical and major experimental pressure gauge. The hint that give is 1. A piston of known area A is loaded by a known weight F. Therefore, the theoretical pressure FTH in the cylinder is PTH equal to F over A in unit kN over meter cube. Second, measure experimental pressure FMEA can be obtained from the reading of the Bourdon tube pressure gauge. Mass of piston is 1 kg. Cross-sectional area of the piston is 3.1731 times 10 to the power of negative 4 meter cube. Acceleration due to the gravity is 9.81 meter per second. So the true pressure exerted by piston is mass of piston times 9.81 Newton over cross-sectional area of piston. So it will become 1 times 9.81 in Newton over 3.1731 times 10 to the power of negative 4 meter cube times 1 kN over 1000 N, and it will become 30.9 kN over meter cube. True pressure exerted by total mass is total mass weight plus piston times 9.81 over cross sectional area of piston. So it will become 1 plus 0.5 times 9.81 Newton over 3.1731 times 10 to the power of negative 4 m squared times 1 kN over 1000 Newton, and it will become 46.4 kN over meter cube. Next, average reading of calibration pressure is 30 plus 31 plus 30 in kPa over 3 times 1 kN over 1 kPa, and it will become 30.3 kN over meter cube. Next, percentage error. For loading equal to measure value minus actual value over actual value times 100%. That is the formula of percentage error. And for loading is 30.3 minus 46.4 minus 46.4 times 100, and it will become 34.7%. For unloading, it will become 40 minus 46.4 over 46.4 times 100, and it will become 30%. For the second question is source of error and method to minimize the error. For the error in this experiment is parallel error. A bubble trapped inside the tube. Reading of Bourdon gauge decreases slowly and piston is not static when dead weight change. For the solution of the error is the eyes of observer must be perpendicular to the scale of reading. Remove the air bubble by rotating the piston slightly. And last one, take the reading after a few seconds to ensure the point is stable. The next question is repeatability and accuracy of this equipment. Repeatability is the closeness of the arrangement between the result of successive measurement of the same measure when carried out under the same condition of measurement. Accuracy is the closeness of the result of a measurement, calculation, or specification conform to the correct value or a standard. The accuracy of the result can be improved by repeating the experiment. So let's go for the conclusion. In conclusion, the objective of this experiment is achieved, which is to calibrate a bonded tube pressure gauge using dead weight. The bonded gauge is normally used to measure the gauge pressure, which is the pressure difference between the pressure in the device with the atmospheric pressure. The experimental value for the measured pressure is used to compare with the theoretical value by using the formula given and the result that we obtain in this experiment. The error in this experiment is parallel error, so that the value must likely differ. Next, the air bubble trapped inside the tube so that the value of experiment become different. Reading of bonded gauge decrease slowly and the piston is not static when dead weight changes. The solution for the error in the eyes of the observer must be perpendicular to the scale of the reading to get accurate reading. Other than that, the air bubble must be removed by rotating the piston slightly. Next, the observer must take the reading after a few seconds to ensure the pointer is stable. So let's go for the reference. Here the reference that we got to finish this lab, to finish the experiment 6. So that's all from us. Thank you.